You're welcome. Before I start solving question, I'll give you a little advice. It is expected of you to know how to solve some question very fast, and then you need the basic knowledge of mathematics like division, multiplication. It is very essential. You need to know your variation, proportion, ratio very well. So if you are very sound, you are not going to have problem in solving so many questions in physics. Another thing that I discovered is students used to say we have a lot of formulas in physics. Why are you cramming formula? Just understand the concept. When you understand the concept, you won't need to cram formula. Like I used to tell my students, I don't cram formula. Since when I was very young, I don't cram anything. But I used to understand the concept. Now the concept will make me to get the formula. So after understanding the concept, that is when I try to cram the formula. Most time I don't cram. So, but the concept will always bring back the formula. Yeah, let's get started. The first question which we are going to solve is this. Now it's very simple question. The inner diameter of a test tube can be measured accurately using a before I continue solving, I skip my mind. Now get your pen, your book. Don't even get calculator, or if you want to get it. Now be as fast as possible because I want to time myself. Now the first one, the inner diameter of a test tube can be measured accurately using a micrometer screw gauge, B pair of dividers, C meter rule, D pair of Vernier caliper. The correct answer here is pair of Vernier caliper. It's not as if you cannot use any other device to measure the inner diameter of a test tube, but the perfect one is the pair of Vernier caliper. You cannot use this micrometer screw gauge. It's very small, so you can't use it. You can use this guy pair of divider, but you will need your meter rule. So which means you are going to use two devices, but the perfect one is what? Pair of Vernier caliper. The next one, two bodies have masses in the ratio 3:1. They experiences force which impart to them acceleration in the ratio 2:9 respectively. Find the ratio of forces the mass experience. It's very simple. Since you are given the ratio of the two masses and you are given the ratio of the accelerations, so let's go ahead and solve our question. Given that m1 ratio m2 3:1, that is the ratio of the mass, a1 ratio a2, which is our acceleration 2:9, then you have, don't forget that from the concept of inertia, from Newton's first law of motion, which is also known as what? Law of inertia, we already know that force is equal to what? The mass times acceleration. Now force is equal to what? Mass times acceleration. Yeah, F1 will be what? Mass 1 multiplied by acceleration 1, which is equal to what? You now put their their ratio, which is 3 times 2, which is equal to 6. The same thing, F2 is equal to what? M2 times A2, which is what? 1 times 9. That will give you 9. So therefore F1 ratio F2 will be what? 6:9. As usual, ratio you have to reduce it, divide both sides by 3, so you get what? 2:3. Now the next question, particle of mass 10⁻⁻2 kg is fixed to the tip of a fan blade which rotates with angular velocity of 100 rad per second. If the radius of the blade is 0.2 meter, the centripetal force is, this one as well is simple. This is what? Circular motion. Don't forget that the force that will keep an object moving around the circular path is known as what? Centripetal force. So which means if there is a force that will make an object to move around the circular path, it means there is another force again that will not make an object to move around the circular path, which is known as what? Centrifugal force. Centrifugal force will be acting to push any object away, while centripetal force will try to keep an object moving around the circular path. This is coming from Newton's third law of motion that state that what? Action and reaction are equal but opposite, or for every action there is equal and opposite reaction. Now let's see how to solve it. You are given what? The mass 10⁻², which is the same thing as what? Is 0.01 kilogram. Then you have your angular velocity omega, which is what? 100 rad per second. You also know your radius, which is 0.2 meter. Don't forget that centripetal force is equal to what? mr omega square. Omega is the angular angular velocity. Now this omega is also what? V over R. Don't forget, omega is V over R, and you can play with your formula. Since omega is V over R, at the end of the day, you will get this. If you put V over R square, you get V square over R square, and one R will later cancel one R. So that is why centripetal force is equals to what? mv square over R. Now substitute the value. So if you substitute the value, the formula that we are using here is what? Mr omega square, because we are given our omega and our R. So that is why we have 0.1 times 0.2 times 10 square. That will give you 20 newtons. You don't need calculator. Now liquid increases, its surface tension A decreases, B increases, C remain constant, D increases, then decreases. It's very simple. What is surface tension? Now surface tension is a tension force that is normal, that is acting normally to the surface of a liquid. Now, what is tension? Tension is a force that tends to increase the length of a substance. So which means any force that tends to stretch the surface of a liquid, we call it what? Tension. Now, so what about surface tension? Now, surface tension will make your liquid to act like a stretched elastic membrane, as if it is an elastic material. That is the effect of what? Surface tension. It will make the surface of any liquid to act like a stretched elastic membrane. Now we have ways of reducing surface tension. One of the way of reducing surface tension is using detergent, using camphor, and you can as well use your oil. Now another method is increasing the temperature. So increase in temperature will automatically decreases the surface tension. Our answer is decreases the surface tension. The next question is, a ball of mass 0.1 kilogram is thrown vertically upward with a speed of 10 meters per second from the top of a tower 100 meters high. Neglecting air resistance, its total energy just before hitting the ground is. We have different approach in solving this question. So I adopted an approach, and I will show you the approach, because you can see this question at the end of the day, you feel like the solution is different from what uncle is giving us. Now let me show you. Now this is the approach I'm using. You have a ball, you have the height of a tower, and then a ball is thrown vertically upward. But don't forget that in the question, the question is asking you its total energy just before hitting the ground. Its total energy just before hitting the ground. Now, which means that if you throw a ball upward from this vertical height, the ball is going to reach its maximum height before returning back again. Now, since the question is telling us just before hitting the ground, so which means that we are going to calculate all the energy that it has expelled just before hitting the ground. It's very simple. Now you are throwing the ball upward. That ball is going to possess what is known as what? Kinetic energy. You are throwing it upward like this, vertically upward. You're going to possess kinetic energy. What is kinetic energy? Which means kinetic energy of the moving ball. Now, when it gets to that height, it's now going to possess potential energy due to the height. Now, which means the total energy will now be what? The kinetic energy that you use to throw the ball upward, the kinetic energy possessed by the ball, and the potential energy at that spot, at that particular height. You have to add it together. And the first thing you need to know is you need to calculate the maximum height of the projection. So the maximum height here is u square over 2g, coming from maximum height when you are projecting an projectile, which is what? U square sine square theta over 2g. Since you are projecting it vertically upward, which means our angle of projection will be 90 degrees. So sine square 90 degrees is what? 1, because sine 90 is 1. 1 times 1, 1. So that is why our formula is u square over 2g. Now substitute the value. It means that this ball will reach 5 meters. The height of the ball will be what? 5 meters above the tower. Now 5 meters above the tower, the total height will now be what? The 5 meters plus the height of the tower. So that is why we have 15 meters as our total height. Now what is the total energy? The kinetic energy here plus the potential energy. So which is what? 5 plus 15, so which was what? 20 joules. In the solution, in some past question, you see them solving it and getting 5, they are getting 15 joules. I have different solutions for this. Some people are getting 15. They don't consider this potential, this kinetic energy. Now we have another solution again. They are just using this height alone, and they are using it as a reference point to this. So now this approach, this is the correct answer, because we are total energy, that is what they are asking us to calculate. Now the next question is, a car of mass 800 kilogram attains a speed of 25 meters per second in 20 seconds. The power developed in the engine is, so here we are asked to calculate power. Now don't forget, you are given mass 800 kilogram and you are given the velocity of the mass, which is what? 225 meters per second, and the time 20 seconds. Recall, what is power? Work done divided by time. Work done per time. Now work done is still the same thing as what? Energy. So which means power is still what? Energy over time taken. Now which type of energy will this car possess when it is moving? It's going to possess kinetic energy. So which means our power will now be what? Kinetic energy divided by time. What is kinetic energy? 1/2 mv squared. Go ahead and insert your parameters. So you are having 1/2 times 800 times 25 square over 20. You don't need calculator. So 1/2 times 800 will give you 400. 25 square 625. This guy divided by this guy, you get 20. 20 multiplied by 625, you get 1250. Sorry, 1000. So if you multiply 16, so you get 1250. That's 2 times 625, you get 1250. Then don't forget about the 0. That is why you get what? 10,000, 12,050. And then if you convert it to standard form, this is your answer. Let's move to the next question. When the brakes in a car are applied, the frictional force on the tire is: A, is a disadvantage because it is in the direction of the motion of the car. B, it is an advantage because, it is a disadvantage because it is in the opposite direction of the motion of the car. C, it is an advantage because it is in the direction of the motion of the car. D, it is an advantage because it is in the opposite direction of the motion of the car. Now let's look at brake. Now brake will try to act in opposite direction to the direction of the motion of the tire, which means it's going to stop the car, isn't it? So that means the direction of the brake is opposite. Now what are we using brake to do? We are using it as an advantage to stop the motion of the car. So which means the correct answer is D. It's an advantage because it is in the opposite direction of the motion of the car. Now if the stress on a wire is 10 raised to power 7 Newton per meter square, and the wire is stretched from its original length of 10.00 centimeter to 10.05 centimeter, the Young modulus of the wire is. So here we are asked to calculate the Young modulus. And what is Young modulus? Ratio of stress to strain. You are given stress. Yeah, this is your stress. You are given the initial length, which is 10 centimeter, and convert it to meter, 0.1 meter. You are given the second length, 10.05 centimeter. Convert it to meter, you get 0.1005 meter. Calculate the change in the length, which means what? L2 minus L1, which is this, is 0.005. Don't forget, recall, Young modulus is a ratio of your stress to strain. Forget about this. This one is the formula of strain. So stress to strain. Now let's calculate our strain. Strain is E. And what is strain? Change in length over original length. What is your change in length? L2 minus L1. We've done that before. And this is our L1. Put it, you get 5 times 10 raised to power minus 3. It's very simple. You don't need calculator to do this. You have 0.0005 divided by 0.1. This 0.1 this 1 0 here, we cancel 1 0 here, so you are left with what? 0.005. So which is what? 5 times 10 to the power minus 3. Don't forget your Young modulus, E, capital letter E, is what? Stress over strain. Strain is epsilon. This symbol is strain. Now put the value there. 10 to the power 7 times 5 times 10 to the power minus 3. So this is our final answer. You don't even need calculator to solve this. The next one. This is an interesting question. The lowest note emitted by a stretched string has a frequency of 40 Hz. How many overtones are there between 40 Hz and 180 Hz? Now this one is talking about string. It's talking about string. They gave us what? The fundamental frequency here. And then they're asking us to calculate to find how many overtones in between 40 Hz and 180 Hz. Before that, let me quickly explain vibration of string. Now, if you have string, you are plucking your string is vibrating. Now, the first you can get a sound. The first sound you can get here is you can have the first harmonic. Now, first harmonic happens when you are getting the fundamental frequency. This one is what? Second harmonic, which is also known as first overtone. First harmonic, second harmonic, which corresponds to first overtone. This is your fundamental note. Now you can have third harmonic, which is the same thing as second overtone, fourth harmonic, the same thing as third overtone, fifth harmonic, which is the same thing as fourth overtone, sixth harmonic, the same thing as fifth overtone. Yeah, let me explain this. For when you are talking about wave, this is a complete oscillation. So anything that looks like this, don't forget this one is known as what? Stationary wave or standing wave, because we have two different waves traveling in the opposite direction, so they cancel each other. So that is why we have stationary wave. Now here, this one is traveling like this, half a circle. So which means that, don't forget that a full circle is known as what? Wavelength. Distance between crest, two successive crests, or distance between two successive trough. Now, if you have a complete oscillation, what you have there is wavelength. Now, since you know that one complete oscillation is equal to what? 1 lambda. That means half complete oscillation will be what? Half lambda. So yeah, this is the length of the string from here to here. So which means the length of the string corresponds to what? Lambda over 2 for this first harmonic. The second one, complete oscillation, that is why L is equal to what? Lambda. The third one is more than one complete oscillation, that is 1.5 complete oscillation, which is what? 3 lambda over 2. The likes of this one, and the likes of this one, and the likes of this one. At the end of the day, don't forget that V is equal to F lambda. F will now be what? V over lambda. F is V over lambda. For the first harmonic, which is what? The first harmonic where you are getting your fundamental frequency. Your fundamental frequency F1 will be what? V over lambda. Since you know that lambda is what? Is equals to 2L. Go back. Here you see lambda is equals to 2L. This is a mistake. If you make your lambda sort of formula here, lambda is equals to what? 2L here. So which means V over 2L. The same thing with F2, V over L. The same thing with F3, 3V over 2L, 2V over L for F4, for F5, for F6. Now at the end of the day, you can multiply. Now do the ratio. If you do the ratio, this is what you are having. Multiply all through by 2L. You are getting this. And also divide all through by V, which means frequency 1 ratio, frequency 2 ratio, frequency 3. You are getting 1, 2, 3, 4, 5, 6. So which means for string, vibration of string is going to have what? Even and odd harmonic. This is the first harmonic, which corresponds to 1, second harmonic, third harmonic, fourth, fifth. Is going to have even and odd. Now let's go back to our question. Since we know that for you to get first harmonic is now our normal fundamental frequency, the second harmonic you multiply 2 by the first one, third harmonic you multiply 3 by the first one, and the like. So yeah, let's solve the question properly. Given that the lowest notes, first harmonic or fundamental notes, F is equals to 40 Hz. What is the range of our note? 40 Hz to 180 Hz. Now for string, the first overtone, which is the second harmonic, is equals to 2F. 2 times 40, 80. The second overtone, which is known as is the third harmonic, 3F, you get 120. Fourth, 4F, you get 160. Sorry, third overtone, which is fourth harmonic. Fourth overtone, which is fifth harmonic, you get 5 times 40, that's 200. Don't forget between 40 and 180. So which means between 40 and 180, how many overtone do we have? We have 3. Why? That's the first one. This is the first overtone, second overtone, third overtone. You see that the fourth overtone is more than 180, so that is why we have 3 overtone. If a sound wave goes from a cold region to a hot air region, its wavelength will A increase, B decrease, C decrease, then increase, D remain constant. Now don't forget that sound wave will travel faster in liquid compared to air. The speed of sound is more in air in liquid compared to gas. And if you are transiting from liquid to solid, the speed of sound in solid will be more than the speed of sound in liquid. So which one is the greatest? The speed of sound in solid first. The next one to be speed of sound in liquid. Then the last one, speed of sound in air or in gas. Now this question is still asking us the speed of sound in gas, but at different temperature. Now, if sound wave goes from a cold air region to a hot air region, its wavelength will to understand this, since sound is coming, is having a frequency will be constant. We all know that, but wavelength can change. Since we know that V is equals to F lambda, so let's make our V sort of formula. Let's make our lambda sort of formula. V is equals to F lambda. So lambda is equals to what? V over F. V over F. Since our frequency is constant, we are talking about speed here. So what we need to know is, let's see if the speed of the sound will increase or decrease when sound wave goes from cold air region to hot air region, since speed is directly proportional to wavelength. So increase in speed will lead to what? Increase in wavelength, and decrease in speed will lead to what? Decrease in wavelength. Let's see how to solve it now. If air is traveling from if sound wave goes from cold air region to hot air region, let's see what will happen. Now, hot air region, there is a lot of activities that will be taking place in hot air region. You see that the molecules of the air, the kinetic energy has already increased in the hot air region. So we already have kinetic energy in place. The molecules of the air are already moving. So which means that we have more volume. Don't forget that volume increase with what? Temperature. We have more volume of air. And at high increase in temperature, you have low density of air. Now, this question is having a lot of controversies as well. Some people are saying increase, some people are saying decrease. And let me show you. Now, you discover that if you are talking about the density of air is more than the density, or is less compared to the density of liquid, and the density of solid is the greatest. And let's look at the speed of sound in all the medium. You see that as density increases, the speed of sound also increases. The speed of sound also increases. Now, which one will have the highest density? Is it the cold air or the hot air? You discover that the cold air will have the highest density. So we can assume that, okay, since the Earth here is going to have low density. That means the speed of the sound in the Earth here will be small compared to the speed of sound in the what? In the cold air. And since the speed is small, what will happen to what's it called, wavelengths? According to the formula that I've shown you, V is equals to F lambda. Lambda is equals to V over F. So the same thing, since the speed is going to reduce, so you should know that the wavelength is supposed to decrease. Now there is another school of thought that is now telling us that no, the wavelength will increase as well. But you should know that the wavelength should automatically decrease because the density of air. Now, why am I saying that the speed is going to decrease? This is another approach. Now, we are talking about air, we are not talking about water. At DMB, we are talking about water at a very low temperature, below 4 degrees Celsius. You know that the density of ice will what? Any temperature below 4 degrees Celsius, anomalous behavior of water. You see that the density of ice is less compared to the density of water. That is also the mystery of water. But we are talking about air here, so we should know that the density decreases with what? Temperature. So as density increases, we should know that the speed of the sound in cold air will be more compared to the speed of sound in hot air. So the speed of sound in a hot air will be less. So which means that as the speed decreases, using our formula here, lambda is equals to V over F, because V is equals to what? F lambda. So you should know that our correct answer is B, decreases. Now the next question is, the equation of wave traveling along the positive x direction is given by y is equals to 0.25 times 10 to the power minus 30 sine, open bracket, 500t minus 0.025x. Determine the angular frequency of the wave motion. I know students should be familiar with this. This is one progressive wave. Now progressive wave equation, I explain it here. This is all the formulas here. It's very simple. Let me explain. Since wave can be represented using a sinusoidal graph, that is why we have a sine function here. Y is equals to what? A sine omega t. Why this omega t is known as what? The phase angle of your wave. Now, if you are talking about different particles at different points, so that is why we are having this phase change here. This phi, capital delta phi, this symbol minus the phase change. Now, omega is what? 2 pi f. This phase change is as a result of what? This guy, x and lambda, because we are taking two positions in our wave. Don't worry, I've done a video that explains this better. That is why we have all this formula. Very simple. Just compare and contrast your formula. A sine 2 pi ft minus 2 pi x over lambda should be equals to what? This, what you are given in the question. Well, let's compare and contrast. You should know that this one corresponds to our amplitude here. Everything here corresponds to our amplitude. Now, which one looks like our omega? Because the question is asking you to calculate omega, because you are asked angular frequency. They ask you to calculate angular frequency. Angular frequency means what? Angular velocity. They are not asking you to calculate frequency. So, oh yeah, which one represents your omega t here? Your omega t should be 500t. That is why you have omega t is 500t. Divide both sides by t. So our omega, which is our angular frequency, is this. Now look, note, angular frequency is the same as what? Angular velocity. Angular frequency is the same thing as what? Angular velocity. Angular frequency is a scalar. Angular velocity is a vector quantity, but they are the same. Frequency is different from angular frequency. The next question is, a 3000 watts electric cooker is to be used on a 200 mains circuit Which of the fuses below can be used safely with the cooker? Now, fuse has a rating. They will write it 2 amp, 3 amp, 4 amp, 20 amp. That's what they used to write on a fuse. They have a current rating. So if you are trying to use any device that will consume more current than the actual than the fuse, more than the fuse, that fuse will get burnt. So that is why you need to calculate the current that your device is using, so that you will now have a fuse that have the capacity of the current that your device is going to use. So you can make your fuse in a way that it is going to be slightly above the current that your device will use. And let's see how to solve it. So you should know that what they're asking you to do here is calculate your current. Now you are given the power 300 watts, you are given the voltage 200 volts. Now electrical power is equal to what? IV, isn't it? Now I multiply by 200 will give us 3000. Make your eyes the formula here, 3000 over 200, that is 15 amp. Now the current rating of a fuse must be slightly greater than the actual current used by electric device. Therefore the fuse required will be what? 20 amp. So you can't use 15 amp as a fuse because it will get burnt. So you have to use a fuse that is more than the actual current that your device is using. Now, a gas at a constant volume of V0 in a container at pressure PO is compressed to 1/5 of its volume. What will be its pressure if the magnitude of its original temperature T is constant? Expect this kind of question, and they will not give you any value, and they ask you to calculate your question. It is ratio and proportion. Let's see how to solve it. Let me show you. A gas at a volume of V0 in a container at pressure PO is compressed to 1/5 its volume. So which means it is reduced to 1/5 of its original volume. What will be its pressure if the magnitude of the original temperature is constant at constant temperature? Now you are given the initial volume V0, initial pressure PO, final volume VO divided by 5, compressed to 1/5. Final pressure, let's use X. At constant pressure, what do we have? We have Boyle's law. P1 V1 is equals to what? P2. So P1 V1 is equals to P2 V2. Boyle's law. Now you have P0. Don't forget that we have related our pressure. So which means P0 multiplied by V0 is equals to what? The final pressure multiplied by the final volume, which is what? V0 over 5. Cross multiply, you get P0 V0 multiplied by 5 is equals to X V0. Make your X out of formula. That means V0 will cancel V0. V0 will cancel V0 here. So you are left with what? 5 multiplied by P0. So if you reduce your final volume by 1/5, you have reduced it to 1/5. You should know that your pressure will also what? Be increased. You are going to multiply 5 by your initial pressure. We say that, don't forget, Boyle's law is telling you that the volume is directly proportional to pressure, or sorry, it's inversely proportional. If something is inversely proportional to each other, as one is increasing, the other one will decrease. As one is decreasing, the other one will increase. That is what happened here. The next question: a piece of substance of specific heat, this is a mistake, heat capacity 450 joule per kilogram per Kelvin, falls through a vertical distance of 20 meters from rest. Now I can bet this with you. Some of my students will see this kind of question, if not the same question. I assure you guys, they love this question so much. Now a piece of substance of specific heat capacity 450 joules per kilogram per Kelvin falls through a vertical height 20 meters. Calculate the rise in temperature of the substance on hitting the ground when all its energy are converted into heat energy. Now, at that height, you should are expected to know that the substance is going to possess potential energy, and the potential energy will be transformed to what? Heat energy. Very simple. Given that the specific capacity is equals 450 joules per kilogram, you are given the height of the substance, you know the acceleration due to gravity, potential energy have transformed into heat energy. mgh is equals to what? mc change in theta. Make your change theta side the formula. You get what? Divide both side by m and divide both side by c. So you get gh over c. Insert your value. 10 times 20 over 450. 20 over 45. Then reduce it. 5 in 24. 5 in 45, 9. That's 4 over 9 degree. That's 4 over 9 degrees Celsius. The next question. A liquid boils when its saturated vapor pressure is equal to the external pressure. Dissolved substance in pure water lead to increase in the boiling point. That is the second statement. The third statement, when the external pressure is increased, the boiling point increase. The fourth statement, dissolved substance in pure water decreases the boiling point. If you have watched the video, you should be able to get this question correctly. A liquid boils when its saturated vapor pressure is equal to the external pressure. Yes, this one is correct. Dissolved substance in pure water lead to increase in the boiling point. Yes, this one is correct. When the external pressure is increased, the boiling point increase. Yes, this one is correct. Dissolved substance in pure water decreases the boiling point. No. So which means our correct answer is 1, 2, 1, 2, and 3. So we have what? 1, 2, and 3. So that is the correct answer. The next one. The temperature gradient across a copper rod of thickness 0.02 meter maintained at two temperature junction of 20 degrees Celsius and 80 degrees Celsius respectively is. There are some questions you don't know how to solve it, but just look at their units. You'll be able to get it. Now look at the units. Kelvin per meter. So which means change in temperature divided by the thickness. Temperature gradient, whenever you are hearing this word gradient, means division. As it is temperature gradient, that means change in temperature divided by what? The thickness. Yeah, given that the thickness of the rod is 0.02 meter, the temperature of the first junction 20 degrees Celsius, temperature of the second, which is what? 80 degrees Celsius. Then the question is, why am I not converting to Kelvin? Since you are calculating change, even if you convert it to Kelvin, the change will still be 60. So that is why I'm not converting to Kelvin. So you have what? 80 minus 20 over 0.02, which is 60 over 0.02. And if you solve it, this is your final answer. Whenever you are dividing by 0.0 something, this zero, you can just carry them and put it at the front of whatever you have as your denominator. So which means if you have 60 divided by 0.02, all these zero, just carry it. Since it is what? If you are dividing any number by number that are less than 1, that number, your final answer will increase. Let's say 1 divided by 0.5, the answer is 2. But 1 divided by 5, the answer is 0.2. Any number that is below 1, the answer will be increasing. So the same thing with this one. You just carry all the 2 zeros and put it at the front of here. This one was 600 divided by 2. What's 600 divided by 2? I'm sorry, 6,000 divided by 2. That will give you what? 3,000, which is what? 3 times 10 raised to the power minus. That was 3 times 10 raised to the power 3. The next one, calculate the mass of ice that would melt when 2 kilograms of copper is quickly transferred from boiling water to a block of ice without heat loss. I don't expect you to miss this one. Bonus question. This is called what? Mixture method. Specific heat capacity of water is this. Latent heat of fusion of ice is this. Don't forget that the mass of ice, calculate the mass of ice that would melt when 2 kilograms of copper is quickly transferred from the boiling water. That means the boiling water is the initial temperature of this copper and is quickly transferred to what? To a block of ice. The final temperature will be what? 0 degrees Celsius. Oh yeah, which means the heat capacity of the copper The heat lost by the copper is what? Heat gained by the melted ice. And let's see how to solve it. Given that the mass of the copper is 20 kg, the specific heat capacity of the copper 400 joules per kilogram per Kelvin, latent heat of fusion of ice is this. You are given initial temperature of the copper, the boiling water. So it's quickly transferred from boiling water, 0 degrees Celsius. The final temperature of the copper will automatically be what? 0 degrees Celsius. If you put it inside the what? Ice, after a while, it's going to assume the temperature of the ice because it cannot melt all the ice. Now, the mass of the melted ice will be what? Unknown. But yeah, heat lost by the copper is what? Heat gained by the melted ice. MC change zeta of the copper will be what? MLF. Which MLF means what? The mass of the melted ice multiplied by maybe it's latent heat of fusion of the ice. Now substitute your value. 20 times 400 into brackets 100 minus 0 is equals to what? M mass of an unknown multiplied by 3.3 times 10 to the power minus 5. At the end of the day, make your M1 set of formula, divide both sides by 3.3 times 10 to the power 5. You get this. 2 times 400 times 100 over 3.3 times 10 to the power 5. And you get 8 over 8 3.3. 8 over 3.3 is still the same as what? 80 over 33. Multiply the denominator and the numerator by 10. So you get 80 over 33 is there. The next question. A man stands 4 meters in front of a plane mirror. If the mirror is moved 1 meter towards the man, the distance between him and his new image is. This one is plane mirror question. Now, for plane mirror, the image is formed at the back of the mirror. We all know that. And the object distance is equal to the image distance. So, the object distance is always equal to the image distance for plane mirror. Now, given that the initial image distance DO is 4 meters, if the mirror is moved closer to the object by 1 meter, then the final distance will be what? DO minus 1. It's moved towards him by 1 meter. So, you should know that the image distance will now be what? DO minus 1, which is equal to what? 4 minus 3 centimeters. Since object distance is equal to image distance, you are also going to have DI minus 1 here. DI is equal to DO. So that will give us 3 centimeters. Now the distance between him and the image will now be what? This distance between the image and the mirror, object and the mirror, plus the distance between the image and the mirror. So which means from here to here. That means you are going to add the two distance. That's 2 times 3 centimeters, 6 centimeters. The main reason for making the cover of a vacuum flask airtight is to prevent heat loss by. Now, which means the cover, it prevents heat loss by what? Convection. It is convection. Don't forget that that same cover is what is responsible for heat loss after a while due to the conduction that will take place inside that cover. It's going to be conducting it. So our correct answer here is not conduction, it's convection. To prevent heat loss by convection. But after a while, that cover will still be absorbing heat due to conduction. And that is why our flask cannot keep hot water for so long, cannot keep it for 4 days. Latest by 2 days. Anything above 2 days, your water, the heat will be lost. The velocity of light in air and in glass are 3.0 times 10 to the power 8 meter per second and 2.0 times 10 to the power 8 meter per second. So if the angle of refraction is 30 degrees, the sine of angle of incidence is. Now this one is coming from Snell's law. And don't forget that Snell's law is talking about the refractive index using sine. What is refractive index? Given that the speed of light in air is 3.0 times 10 to the power 8, speed of light in glass is 2.0 times 10 to the power 8. The angle of refraction is 30 degrees. Don't forget, refractive index N is the same thing as what? The speed of light in air divided by speed of light in another medium. This time around it is glass. And it's still the same thing as what? Sine of the angle of incidence to the angle of refraction. This one is from Snell's law. Now, which means sine I over sine theta will now be what? Insert the value of your velocity. You get this and this. Make your sine I set the formula by doing cross multiplication. What is sine 30? 0.5. Multiply by this, you get 1.5 times 10 raised to power what? 8. Now 1 over 2 is what? 0.5. 10 raised to power 8, we cancel 0. 10 raised to power 8. So what is now sine 30 is what? 0.5. 0.5 times 3 will give you what? 1.5. 1.5 times 0.5, that's why you are getting to get 0.75. Try this yourself. Try and solve this yourself. Now the next question is the inside portion of part of a hollow metal sphere diameter 20 cm is polished. The portion will therefore form a, this one is too cheap. Now we are polishing the inside portion of a hollow metal sphere of diameter 20 cm. Now you are given, don't forget that focal length is what? R. Look at the option. They are talking about focal length and the type of mirror. So that means we need to calculate our focal length. Focal length is what? Your radius of curvature of the mirror divided by 2. Don't forget that in the question, you are not given radius, you are given diameter. So given that the diameter is 20 cm, what will now be your radius? D over 2. So that will give you what? 10. Since F is R over 2, and you know that R will now be F is what? R over 2, and D is equal to what? R is equal to D over 2. That means F will now be what? D over 4. Or simply calculate your radius, which is 10 cm, and your focal length will now be what? 10 divided by 2. That will give you what? 5. Or you use D over 2 is our what? Is our radius. Insert it in your formula. At the end of the day, you get F is equal to what? D over 4. 20 divided by 4. You see, you still get 5 cm. Since the inner portion is polished, the mirror will be a convex. You should know that when you polish the inner part, you are getting a convex. When you polish this inner part, when you polish this outer part, you are getting a concave mirror. So the mirror will be convex with focal length 5 cm. An astronomical telescope is said to be in normal adjustment when the A, I is accommodated, B, focal length of the objective lens is longer than that of eyepiece, final image is at the near point of eyes, the image is at infinity. Now the correct answer is the final image is at infinity. Why are we doing this to is for your astronomical telescope? We are going to have two type of lens, the objective and we have the objective lens and the eyepiece. Now they are going to do this arrangement in such a way that your image will be formed at infinity. Don't forget that if image is formed at the infinity, your image will be large. If you are using a a telescope to view an image that is an object that is at infinity is very far away, and you are using your telescope to bring it close to you and you are able to view it. Now what you're actually doing is, at normal adjustment, the image will always be formed at infinity. You can check your textbook and consult that. Which of the following electromagnetic wave is least energetic? We are talking about electromagnetic wave this time around. We have gamma ray, ultraviolet ray, we have X-ray, and we have infrared. Now the one that is least energetic, if you are talking about energetic, let's look at energy. This one is electromagnetic. Let's look at wave particles. Which nature of particles? Now let's look at it. Don't forget that H is equal to what? Our energy is equal to, according to Planck constant, energy is equal to HF. Energy is equal to what? HF. Planck constant multiplied by the frequency. Now since this is wave, they are going to have frequency, which means the one that is having the highest frequency we have the highest energy, will be the most energetic. Now gamma ray will be the most energetic, followed by what? Followed by X-ray, then followed by ultraviolet, then followed by infrared. So the least one is infrared. The next one is steel is more suitable for permanent magnets than iron because the former, that means we are talking about this steel. A is easily demagnetized by shearing vigorously. B is an alloy of many metals. C is easily magnetized by alternating current through one circle. D retains magnetism more than iron. The correct one is retain magnetism more than iron. Now, don't forget that steel is an alloy of iron and carbon. So they are using iron and carbon to make steel. The carbon contents. Now, so is an alloy of many metals. No, wrong. Steel retain magnetism more than iron, but iron easily magnetized than steel. For steel to magnetize, it takes more energy, but once it's magnetized like this, it retains its magnetic properties. That is why steel will be used to make permanent magnet, and iron is basically used to make temporary magnet. 4 cell each of EMF 1.5 volts and internal resistance of 4 ohm are connected in parallel. What is the effective EMF and internal resistance of the combination? Let me explain this. For parallel combination of cells of the same EMF, the effective EMF is 1 EMF of the cell. If you have a cell is also a battery, and they are arranged in parallel, and they are the same values, just pick 1 EMF out of it. That is the effective. Let me explain the difference between arrangement of cells in parallel and in series. If you have series, you have to add them together. But if it is a parallel and they are the same, you are going to pick one out of it. If they are not the same, you will use 1 over E total is equals to 1 over E1 plus 1 over E2. But since they are the same, you just pick one out of it. Now, if you are arranging cells in parallel, what you are doing is you are increasing the power. What they're actually doing in power bank is the difference between power bank, regardless of any power bank that you are buying, they are still generating the same volt. The battery inside it is having the same volt. Don't forget, it's not one battery, it's not two batteries. We have the one that is having 2, 1, we have the one that is having 4, 6, 12, and the likes. Now, what they are actually doing is they are just bringing in more battery and they are arranging them in parallel to have the same amount of voltage, but they are increasing the power. So instead of having more voltage, is increasing power when you are connecting cells in parallel. Now, if you are connecting cells in series, the power is the same, but you are increasing the voltage. So you have more voltage, while the power, you sacrifice voltage for power. You sacrifice power for voltage. But when you are arranging them in parallel, you are sacrificing voltage for power. So don't forget that power cells is also having internal resistance, and since they are connected together in parallel, their internal resistance will also be connected together in parallel. So what you need to do here is calculate the total resistance. This is resistor in parallel. Let's calculate 1 over total is equals to 1 over 1 plus 1 over 2 plus 1 over 3. Now, given that the EMF is 1.5 and the internal resistance of those EMF of those batteries 4 ohms, the effective EMF will also be 1.5. Picking one, calculate your total resistance. You should be able to do this. That will give you 4 over 4, which is 1. So our answer is 1.5 volts and 1 ohm. The next question, an interesting question. Number 26 question. A galvanometer has a resistance of 5 ohm by using a shunt wire of resistance 0.05 ohm. The galvanometer could be converted to an ammeter capable of reading 2 amp. What is the current through the galvanometer? This is one of the questions I used to tell students. Don't cram formula. Let's see how to solve it. Don't forget that, recall that a shunt is a low resistor that is connected to galvanometer or milliammeter in what? In parallel, to convert it to an ammeter. And what we are using shunt to do is we are using it to increase the range of our galvanometer. Galvanometer is a device that measures small amounts of current. It's a deflecting device, and it also shows the direction of the flow of current. Now, if you want to increase the range or the resolution, you want to amplify the galvanometer, you want to measure large current, you are going to have a low resistor connected with your galvanometer in parallel. So that low resistor is known as what? Shunt. So you are given the resistance of your galvanometer. You are given the resistance of the shunt. Now in the question as well, you can see question that is talking about at full scale deflection. Full scale deflection is the current, the current that flows in your galvanometer. The current that must get to your galvanometer, it must not exceed that current. So here you are only given the resistance of the galvanometer and the resistance of the shunt. You are given the current that you want to measure. This one is not current in the galvanometer, the range. So you don't know the current in the galvanometer. But don't forget that whenever you have a series parallel combination, the voltage is the same thing. That is what I used to say. Vg is equals to Vs. Voltage in the galvanometer is the same thing as voltage in the shunt. So which means don't forget V is equals to IR. Ig will be the same thing as what? Rg will be Rs. And since we have parallel combination, the current is going to split into two, which means the current I will now be what? I1 plus I2. That is Ig plus I shunt. That is what we have here. That is what we have here. So you can just make your I shunt solve the formula. If you make your I shunt solve the formula, will now be your what? The current given in the question minus the Ig. Now put the value inside this formula. This is the formula that we want to use to solve our question. So we have already made IS, the formula IS is because the question is actually asking us to calculate Ig. So instead of making IS the formula, we can make Ig the formula. Sorry. Now that means Ig will be what? I minus Is. Just make it the formula. Ig is equals to what? I minus I shunt. Now just put it inside this formula. We are done. What we are ensuring is we want to have a formula that will accommodate what we are given: Rg, R shunt, I and Ig. So we don't have anything to do with I shunt. So wherever you are seeing I shunt, just make your Ig the formula here and put it in your formula. That's all. That's what I did. Now let me show you. Now you have this is it. Ig Rg is equals to Is Rs. Don't forget that Is will be what? I minus Ig. Just put it in this formula like this. Write this first, which is this. Is the same thing as this, Abi. Now instead of having Is, you have what? I minus Ig into brackets Rs. Now expand this. You have what? IRS minus IGRS. So which will lead to what? This. Now bring your Ig out. You get Rg plus Rs. And if you bring it out, is equals to what? IRS. And then make your Ig the formula, which is what? IRS over Rg plus Rs. And put your value. So you are going to get this. Try to solve it yourself. This is the formula that I use. Don't let all this convince you. This is the formula that I use. I just substitute. Now since I'm giving this current and I have all these values, this is what I'm looking for. I'm looking for Ig. And I know the value of Rg Rs. I don't know the value of Is. Now instead of having Is here, just make it a sort of formula, because you know that your I is equal to Ig plus Is. Just go ahead and put everything inside this, then you get your answer. The next question: in Fleming's right hand rule, the thumb, the forefinger, and the middle finger is held mutually at right angles, represent respectively the in Fleming's right hand rule, the thumb, the forefinger, and the middle finger, if held mutually at right angle, represents respectively the. Now this one is Fleming's right hand rule. Now Fleming's right hand rule is a rule for generator. It's talking about rules for generator, while Fleming's left hand rule is talking about motor, electric motor. This one is talking about generator, right hand rule. Now it's very simple. We have motion, the field, and the induced current is the correct answer. Fleming's right hand rule. At what frequency would a 10 Henry inductor have a reactance of 2000 ohms? Let's see how to solve it. You are given the inductance of your inductor 10 Henry. You are given the inductive reactance, which is 2000. This is it. And you are asked to calculate what the frequency or no. Recall that XL, your inductive reactance, is what? 2 pi FL. So we are asked to calculate frequency. Make your F set formula. That will give us XL over 2 pi L. Insert your value, 2000 over 2 times pi times 10. That will give you what? 100 over pi at. Next question: the core of an efficient transformer should consist of laminated pieces of metal. In order to these questions, you will see it. Now the core of an now is very simple. Why are we laminating our core in transformer? We have some energy loss in transformer. Energy can be lost due to eddy current. Now energy can be lost in form of flux leakage. We have flux leakage. Another one is we have the I square R, that means in form of heating. We have heating. Energy can be lost in form of heating, and energy can also be lost in form of what we call it hysteresis. So that is the 4 ways by which energy can be lost in your transformer. Now the one that is talking about eddy current can be minimized using what? Using laminated pieces of iron. Let's look at it. The correct answer will now be what? Increase. Now the core, in order to reduce the heat by reducing eddy current, is the correct answer. So which means reduce the heat produced by reducing the eddy current. Now gamma rays are produced when A, high velocity electrons are abruptly stopped in metal. B, energy changes occur within the nucleus. C, energy changes occur within the electronic structure of atoms. D, electrons are deflected in a very strong magnetic field. Now let me explain it. I will explain the correct answer. I will choose the correct answer. The correct answer is this: energy changes occurs within the nucleus. Now this one, high velocity electron are absolutely stopped in metal. This is the production of X-ray. This is the definition for X-ray. X-ray is produced when fast moving electron collided with an obstacle, just like a metal, and is trying to decelerate the electron. So a ray will be produced, which is known as what? X-ray. For this one, this is generation of what? Gamma ray. This is how to produce gamma ray. Energy changes occurs within the nucleus. What is the speed of a particle of mass 10 raised to the power minus 27 kg whose wavelength is 10 raised to the power minus 8 meter? You are given the Planck constant 6.63 times 10 raised to the power minus 34 joules per second. Now let's see how to solve that. You are given mass, you are given wavelength, you don't know the speed, you know your Planck constant. Don't forget this from the block graph. We know that our lambda is equals to what? H over P. Your P is the momentum. while h is Planck constant. This formula as well, I can solve this formula without even this question without using the Broglie equation. I was once time I solved question like this, and I told the students that I use Albert Einstein formula. Energy is equal to what? Hf, and it's still the same thing as what? mv square or mc square. Now this f, v is equal to f lambda, so f is equal to what? Lambda. V is equal to f lambda, and f will be what? V over lambda. Instead of having f here, we can have v over lambda. If you have v over lambda here, v will cancel the square. One v is gone here. You are left with what? H over lambda is equal to v. You are trying to make your lambda side the formula. You see that lambda will now be what? H over mv. You see? Now, where p is equal to momentum mv, substitute the value. Just substitute your values here. You don't need a calculator to do this. Substitute your value, cross multiply, divide both sides by 10 raised to the power 35. That will give us what? 10 raised to the power minus 34 divided by 10 raised to the power minus 35. So you are going to be left with what? 110. 10 multiplied by 6.63. You get this. Pause it and solve it yourself. In a series RLC circuit at resonance, the voltage across the resistor and inductor are 30 volts and 40 volts respectively. What is the voltage across the capacitor? I won't solve anything here. I will just explain it. At resonance, you should know that XL is equal to what? XC. Your inductive reactance is equal to capacitive reactance. So don't forget that this is series combination. You should know that the same current will pass through all your components. And if the same current is passing through, what is XL? V is equals to IX, isn't it? V is equals to IX, isn't it? Now, since XL is equals to XC, so V for capacitor is equals to what? IX capacitor, isn't it? And V for, what's it called? Inductor will be what? IXL for inductor. Since their current is the same, XL and XC is the same. So that means their voltage will be the same. So our answer is 40. In the Rutherford scattering experiment, a beam of alpha particle was fired at a thin gold film, with some of the particles being considerably deflected. This shows that a gold nucleus contains protons, neutrons, and electrons uniformly distributed in tiny volume. The gold nucleus is positively charged and it is concentrated in tiny volume. The gold nucleus emitted alpha particles. The gold nucleus is concentrated in a tiny volume and contains alpha particles. Now, what is alpha particles? They are positive, right? Now, if in the Rutherford scattering experiment, if anything is deflected, you should know that we have the same charge. Don't forget that from the law of electrostatic, positive charge, the same charge repel, like charge attract. So which means that since this guy is positive, alpha particle, for it to be deflected in gold leaf, when it is fired against the gold film, it means that the gold film is also positive. So the gold nucleus is positively charged and is concentrated in a tiny volume. That's the correct answer. Now 2311Na, this is the mass number, atomic number of plus proton is equals to pqx alpha particles. What is the value of pq respectively in the equation? You should know that proton is what? 1, isn't it? Now if proton is 1, you are adding it with 1. Don't forget the concept of chemical equation. Now that means now since we are having alpha particles, so there is nothing here, so it means that you add 1 to 23, add 1 to 11. That is why you have 24 and 12. So P will be what? 24, Q will be what? 12. If change in X is the uncertainty in the measurement of position of a particle along the x-axis, and change in the momentum in direction of x is the uncertainty in the measurement of the linear momentum along x-axis. Then the uncertainty principle relation is given as. Try to know this kind of question. JAMB loves it as well. Now the correct answer is change in uncertainty in the position multiplied by that of the momentum will be greater than or equals to Planck constant. Greater than or equals to Planck constant. A is the answer. Now when a ship sails from salt water into fresh water, the fraction of its volume above the water surface will A increase, B decrease, C remain the same, D increase then decrease. Let me quickly explain this. When ship sails from salt water is having high density. Density is high. So don't forget that upthrust is directly proportional to density, isn't it? Since upthrust is directly proportional to the density, and upthrust is responsible for the fraction of the ship that will be in water, or the fraction of ship that will be above the water. So which means if upthrust is very high, the fraction of the ship above the water will also be high. That is the definition for upthrust, will also be high. And salt water is having high density. So high density means what? High upthrust. So since the ship is flowing from high density into fresh water that is having low density, so that means the upthrust will be low, will be reduced. That means the fraction of the volume, the fraction of its volume above the water surface will also what? Will also reduce. So which means it will decrease. When it is sailing from salt water into fresh water, the fraction will decrease. But when it is sailing from fresh water to salt water, the fraction will increase. So the correct answer here is what? The fraction will decrease. B is the correct answer. The next question. A semiconductor diode is used in rectifying alternating current into direct current mainly because it A. allows current to flow in either direction, B. it is non-linear, C. offer high input resistance, D. allow current to flow only in one direction. I don't expect any of my students to miss this. Allow current to flow only in one direction. Now it's very simple. This is the symbol for your diode, schematic of diode. Use of diode is used for rectifying, which means convert AC to DC in an AC circuit. For voltage regulation, a special type of diode that is used for voltage regulation is known as Zener diode. It's used for light source. All our white bulb at home, LED, light emitting diode. Current can only pass in forward direction for diode. Forward bias. Current will not flow in backward bias. Its velocity is constant. No work is done on the body. It has constant acceleration directed away from the center. The centripetal force is directed towards the center. Which of the combination above is true of a body moving with constant speed in a circular path? Its velocity is constant. No work is done on the body. No. Velocity is constant. No. Its constant acceleration directed away from the center. Yes. And the centripetal force is directed towards the center. Yes. So which means 3 and 4 is the correct answer. So we don't have correct option here. 2 and 4, let me check. No work is done on the body. No. 1, the velocity is constant. No. So 3 and 4, maybe I'm the one that actually made mistake while I was typing this question. Maybe A is the correct answer. 3 and 4 is the correct answer. The velocity ratio of a machine is 5 and its efficiency is 75%. What effort will be needed to lift a load of 150 Newton with the machine? A, 20 Newton. Let me show you the solution. You are given the velocity ratio, which is what? 5. Your efficiency in the question, the efficiency is 75. You are given the load. you don't know the effort. Now, what is efficiency of a machine? Mechanical advantage over velocity ratio. Why is it that efficiency of a machine is not 100%? It is due to friction, and it is due to the fact that this velocity ratio is always greater than mechanical advantage. Now, let's make mechanical advantage solve the formula. Mechanical advantage is what? The efficiency multiplied by velocity ratio over 100. Now, input your data. So that was 75 multiplied by 5 divided by 100. 375 divided by 100. That is our mechanical advantage. And don't forget that mechanical advantage is the ratio of load to effort. Machine is giving us advantage to overcome a load. That is when we say mechanical advantage. There are some stupid machine that can give you disadvantage. Any machine that is giving you disadvantage is not known as machine. It's just stressing you. Now, cross multiply to make your, since 150 is our load and we are looking for effort, over effort is our mechanical advantage. 375 over 100. Cross multiply, you get 150 times 100 is equals to effort times 375. Divide both sides by 375. You get this. Pause this question and pause this video, and or you screenshot it and solve the question yourself. Your answer is 40 Newton. At a fixed point below a liquid surface, the pressure downward is P1 and the pressure upward is P2. It can be deduced that, don't forget that in my video I've explained this as well in the previous video that you've gotten. Now, at the fixed point below a liquid surface, the pressure downward is P1 and the pressure upward is P2. It can be deduced that, now I explained the fact that pressure increases with depth. You should know that it increases with the depth. So it can be deduced that P1, since the pressure downward is P1 and the pressure upward is P2, it can be deduced that P1 should be greater than P2, since at the fixed point below a liquid surface, P1 is greater than P2 is the correct answer. And the next question, if the force and the velocity on a system are each reduced simultaneously by half, the power of the system is, expect this kind of question. Let's see how to solve it. The first step is to understand the concept of power. Power is what? Work done over time. What is work done? Force times distance. And what is power? Force times distance divided by time. Distance divided by time is our velocity. That is why we have power is still the same thing as what? Force times velocity. So power is directly proportional to force and velocity. If force and velocity is reduced by half, then the new power will be what? Force is reduced by half, that means force divided by 2. Velocity is reduced by half, velocity divided by 2. You multiply the two guys together, that means force times velocity divided by 4. And don't forget, force times velocity is our power. Power divided by 4. Therefore, power is reduced by quarter. Quarter means divided by 4. It is reduced to quarter. A catapult used to hold a stone of mass 500 grams is extended by 20 centimeters with an applied force F. If the stone leaves with a velocity of 40 meters per second, the value of F is, you are given the mass of the stone, you are given the extension, and you know the velocity. Let's see how to solve this. Now, given the mass 500 grams, which is what? 0.5 kg. You know the extension, convert it to meter. You know your velocity, and you have to calculate force. Don't forget that the energy stored in the catapult rubber will transform to kinetic energy of the moving stone. So what is energy stored in the catapult rubber? The elastic material, 1/2 Fe. It's still the same thing as what? 1/2 Ke square. It's still the same thing as what? 1/2 F square over K. If you check my video, the previous video very well, when I was talking about energy transformation to heat, you will see all those formula there. Now, it's the same thing as what? 1/2 mv square That means 1 over 2 will cancel 1 over 2. You are left with what? Fe is equals to mv square. Make your F set of formula. F is equals to mv square divided by E. Insert your values. 0.5 times 40 squared divided by 0.2. Then you solve your question and get your final answer. A stream is flowing at 0.75 meter per second and a boat heading perpendicularly to the stream landed at the opposite bank at an angle of 30 degrees. Calculate the velocity of the boat. This one is a vector question, so you have to have an understanding of vector to be able to get it very well. Let me show you. This is the solution. Don't forget, this is a stream flowing. This is the direction of the stream. You have a boat that wants to cross the stream like this, and because the river is flowing in, it's going to be pushing this boat away like this until it crosses the river. This is the final direction. And what is the direction? 30 degrees. Look at the diagram. That is why I have this. This one is the direction of the boat, the velocity of the boat, and the velocity of the river. And this is the resultant. Don't forget, this one is your resultant, the direction of the resultant velocity. This is it, and this is direction 30 degrees. Yeah, let's see. So you know that, don't forget that the direction, while solving vector question, the direction is what? Tan theta is equals to your vector. This time around, this is not force, this is velocity in y direction divided by what? In s direction. That means velocity of the boat divided by what? Velocity of the river. Tan theta will now be what? Vy over vx, and v river will now be what? Tan theta multiplied by what? Sorry, v river will be what? V boat divided by, wow, this is a mistake. Now if you try to make your v river substitute the formula, the question is asking us to calculate what? The velocity of the boat. Sorry. Now if you try to make the velocity of the boat substitute the formula, you are going to have v, not v river this time around. This one will be what? V boat is equals to tan theta multiplied by v river. So v boat can now be, what is tan theta? Tan 30, you get this. V river is already given the question, 0.75. So that is why your answer was 0.433 meter per second. And if you check their options, it is not there. That is the correct answer using vector diagram. The next one, a rope is being used to pull a mass of 10 kg vertically upward. Determine the tension in the rope if, starting from rest, the mass acquires a velocity of 4 meters per second in 8 seconds. Let's see how to solve this. You are given the mass as 10 kg. You are given the vertical velocity, which is what? 4 meters per second, and you are given the time, which is what? 8 seconds. Now acceleration due to gravity is what? 10 meters per second square. That's acceleration due to gravity. Now this is the initial position of the mass. So what will be the downward force? The weight, which is what? Mg. You have the weight, which equals what? Mg. The upward force, which is equals to what? Ma. This is upward force, which is equals to Ma. Now the tension in the string is going to be what? The reaction, the weight of the object minus the force, the upward force. So which means tension will now be what? Mg. The tension in this rope, look at the direction. The tension of this rope will be the what? Your downward force minus the upward force. What is the downward force? The weight minus the mass times acceleration, the upward force. Now in the question you are given mass, velocity, and time. What is acceleration, velocity divided by time? So insert your values and you are going to get this. You can pause it and screenshot and try to solve the question. The friction force is independent of the area of the surface in contact. The frictional force depends on the nature of the surface in contact. The frictional force depends on the speed of sliding. The frictional force is directly proportional to the normal reaction. Which combination of the above is true of sliding friction? The frictional force depends on the speed of sliding. The frictional force is directly proportional to the normal reaction. So one out of it is wrong. Now, which one is wrong? The frictional, remember the laws of friction. The first one, the frictional force is independent of the area of the surface in contact, correct? Force depends on the nature of the surface contact, correct? If it is very rough, the frictional force will be much compared to when it is smooth. The frictional force depends on the speed of sliding. No. The frictional force is directly proportional to the normal reaction. Yes. So which means 1, 2, and 4 is the correct answer. 1, 2, and 4. 3 is not part of it. Next question. Total internal reflection occurs when light moves. I expect my students to get this bonus question. When light moves from a dense medium to less dense medium, air to water, water to glass, a less dense to a dense medium. No. When it moves from a dense medium to a less dense medium. That is total internal reflection. Total internal reflection is also responsible for mirage and the likes. A quantity of water at 0 degrees Celsius is heated to about 30 degrees Celsius. At each degree rise in temperature, its density will... this is the same question that we have solved earlier on. A density of water at 0 degrees Celsius is increased to about 30 degrees. So increase in temperature leads to what? Decrease in the density. So at each degree rise, temperature, its density will rise steadily, fall steadily, fall then rise, then fall. So you should know that the temperature will what? Reduce, which means falls steadily. Look at the solution. Increasing in temperature will lead to increase in volume. Volume is directly proportional to temperature. Density is inversely proportional to volume. Density is equal to mass over volume. Therefore, density reduces with increase in volume when mass is constant. Coherence, same frequency, same wavelength, same intensity. Which of the following conditions above are necessary to produce interference fringes? We have same wavelength, same frequency, and coherence. Now, if something is coherence, which of the following to produce interference fringes? Interference fringes occurs when we have two different traveling waves. They are traveling in opposite direction, and they have the same frequency, the same wavelength. They have of the same nature. So which means same frequency is here, same wavelength is here, and that means 1, 2, and 3, and they must be coherence as well. Boyle observed a piece of stone at the bottom of a river 6.0 meter deep. If it looks from the surface of the river, what is the apparent distance of the stone from him? We are given the refractive index of water as what? 4/3. Let's see how to solve it. Refractive index of a material, N, is equal to what? Speed of light in air over speed of light in water. What material are we talking about here is what? The speed is water. Speed of light in air over speed of light in water. And it is still the same thing as what? The real depth over apparent depth. Yeah, we are given what? The refractive index of water, which is what? 4/3. And what is the real depth of the river? 6.0 meter. The river will appear closer to that boy. The depth will appear closer to that boy, and it is as a result of what? Refractive index. So which is what? 6/x. When you cross multiply, you get 4x is equals to 6 times 3. 6 times 3 is what? 18. X will now be what? 18 divided by 4. That is why we get 4.5 meter. The last question. One end of a long wire is fixed with a vibrator is attached to the other end. When the vibrator is energized, the types of wave generated in the wire are. Now, since we have a vibrator and it is attached to the other end, now we have to understand the concept of stationary wave, transverse wave, and longitudinal wave. Stationary wave is a type of wave that is not transferring energy, while progressive wave is transferring energy. Look at it. One end of it is fixed while a vibrator is attached to the other end. Automatically, the vibrator will be transferring momentum. Since this is wire, it's going to be transferring momentum to the other side. So we should know that we are going to have a progressive wave. Since the two ends are not fixed, we are going to have a progressive wave. Now let's fix the other one. Now, since the vibrator will be vibrating up and down, will be vibrating, and the wave, the particles of that, the wave will be traveling in perpendicular direction. This type of wave is known as what? Transverse, not longitudinal wave. This time around, let me draw the diagram to illustrate this for you. You have a vibrator here attached here, and you have something like this. As the vibrator is vibrating, this thing will be going like this. So which means that what type of wave are we having when the direction of the wave is perpendicular to the movement of the medium of the source? We have transverse wave. That is why the wave is going to be progressive and transverse. The answer is progressive and transverse. It is not stationary. At the end, the two end is stationary, is fixed. We have stationary. Since it is vibrator, it is vibrating. The direction of the motion will not be. This is vibration, and this thing, the wave will be moving like this. So that is why we have transverse wave. Transverse wave. When are you going to have a, what's it called, a stationary wave? A longitudinal wave is when we have, what's it called, moving parallel to the what, to the vibration of the source. Example of transverse longitudinal wave is sound wave. As I'm speaking like this, sound wave is moving straight away parallel. So that is when we have longitudinal wave. I will advise you, although I'm somehow strong, hopefully you guys are not writing your exam on time. I want to release a free video on YouTube, on my YouTube channel, concerning wave and sound wave. Hopefully I should be able to release it by Thursday night. And I know some students are having exam on Friday. There's nothing I can do about that one. Right, take care of yourself.